So we will start with amines. So what are amines? Amines are nitrogen containing organic compounds. Amines are nitrogen containing organic compounds. Containing organic compounds which are basic in nature. Which are basic in nature. It has a free lone pair. Lone pair for donation. That is, it will act as an Lewis base. As a Lewis base. Okay. So the general structure of amines are a nitrogen with 3 groups and a lone pair. Okay. Now, this amines can be classified into 3 categories. Okay, this amines can be classified into 3 categories. The first one is aliphatic amines. The second one is aromatic amines. Today we will focus mainly on the aliphatic amines. So when we are talking about aliphatic amines, they can be further classified into 3 segments. Okay, the first one is primary amines. Then secondary amines. And finally tertiary amines. Okay, primary, secondary, and tertiary. So what is the basic difference between them? Here, the N has 2 hydrogens attached to an alkyl group. In secondary in secondary amine, you can have 2 types, that is a simple and a mixed type. A single secondary amine is where 2 R groups are same and you have only 1 hydrogen. Okay. 2 R groups, 2 alkyl groups are same with only 1 hydrogen, and mixed is 2 R groups are different, R dashed NH. Okay, 2 R groups are different. In tertiary amines also we can have 2 forms, simple and mixed. In simple, you have all the 3 alkyl groups on nitrogen. Okay, same alkyl groups. And in the mixed one, you will have different alkyl groups, R dash, R double dash, N. Okay, in the mixed, you will have all the 3 different alkyl groups. Let us understand in a deeper verse of the structure of an amine, aliphatic amine. So we have just drawn this structure. So regardless of what here is, okay, R dashed H, or as the phlegm RRR, okay, tertiary amine, anything, we can see that this nitrogen, all the nitrogens are sp3 hybridized. Okay, all the nitrogens are sp3 hybridized, that is, they are tetrahedral structures. But what is the basic difference between them and an ammonia? Is their bond angle. Okay, is their bond angle. This is the first difference between ammonia and amines, are their bond angles. What will happen to the bond angles? Here we all know that between nitrogen and hydrogen, nitrogen is more electronegative. So here the bond pair, lone pair repulsion will be higher and the bond angle will be lower. Like here it will be 107 degree. But for this, as the alkyl group has a carbon atom, which is slightly more electronegative than hydrogen, slightly. So you will find that this angle is slightly more than 107, like 100 and nearly 108 degree. Okay, so these are nearly 108 degree. Not that part, this NR part is 107.5 degrees. Okay, so likewise, you will have this change of this. The next comparison will lie in the basic nature. Okay, when we compare the basic nature of amines with ammonia in the gaseous state, we will see that ammonia is least basic, followed by primary amine, then secondary amine, and then tertiary. Okay, in the gaseous phase. This will be in the gaseous phase. Okay, but not in the aqueous phase. Why not? Because in aqueous phase, we will have an extra energy of hydrogen bond. Okay, in aqueous state, we will have an extra energy of hydrogen bond. So I'm coming to it at a later stage. I will comparing the basic nature of ammonia in the aqueous state as well when we will cover the physical properties of the amines. Okay, so first this is the general comparison. Then let us start with the preparation of amines. Okay, how we can prepare an aliphatic amine. Preparation of amines. Okay. So in the preparation of amines, the most important part is that in this segment, we will deal with preparation of amines which are 1 degree amines or primary amines. Okay. Our main focus will be preparation of primary amines. So the first thing is that from where we have started. We have started this from an hydrocarbon, that is alkane, alkene, and alkyne. But when we are talking about alkene, and alkyne, in order to prepare an amine, it is not that much easy because there is no oxidizing agent where we can replace, in which if we suppose we are taking an alkene, so we have to change the hydrogen, we have to replace the hydrogen with an NH2 group. And this is, means what can I say, is nearly impossible to change a hydrogen with an NH2 group. Okay, so we have to do some changes. We have to bring something. In this case, we will start preparing amines from like some other functional groups. Like if I have some chlorine, okay, like alkyl halides, then I can prepare that. Suppose I have an alkene and like I have added water to it in acidic medium to prepare an alcohol. We cannot do that straight away. For just we have to add amine, means an 1 degree or set, or should I say ammonia to an alkene, because an alkene and ammonia will not react in acidic condition. In acidic condition, ammonia will react with that acid because ammonia is more basic than the alkene itself or alkyne itself. So ammonia and alkene will not go side by side and they will not react with each other. Okay. So we have to think of different things. Like at first we have to, then we have to come to our first chapter, which is alkyl halides. So we will first prepare from alkyl halides. Preparation of amines from alkyl halides. Okay. So this process is a fairly tough process because the reaction have to be stopped in a very minute stage, because if we let the reaction to go forward, then a lot of a mixture of products will be obtained. Like if I have RCl, okay, and I add NH3 here, one equivalent. Okay, for one equivalent of RCl, if I add one equivalent of NH3 over an solvent like DCM, so I will get RNH2. Okay, this is 1 degree amine. But if this is in excess, if I have some excess of RCl, like second equivalent of RCl, then I will get 2 degree amine. If I have a third equivalent of RCl, then I will get a 3 degree amine. Okay, I will get a 3 degree amine. And if I have a 4th degree, means fourth equivalent RCl, okay, then I will get a quaternary ammonium salt. Okay, I will get a quaternary ammonium salt. This is known as Hofmann ammonolysis method. This is Hofmann's ammonolysis method. So we have to be very sure about what is the equivalent of uh, alkyl chloride there is in the reaction. So this type of reactions are mainly done in a reverse phase. That is, you first take ammonia and to that you add single equivalent of RCl so that the reaction never gets the time to exceed. Okay, if I have a bulk of RCl and to it if I am adding NH3, so then what will happen? Then the other hydrogens will react with other chlorines and it will not let other equivalent of NH3 to come and react. So one equivalent of NH3 will react with 4 equivalent of RCl. Okay. So in order to stop that, so we have to stop that part. So for stopping that part, we have to take first ammonia in excess and to that we have to add RCl slowly so that the reaction never gets to the point where NH3 is in small amount and RCl is in higher amount. So we can stop this other byproducts. Okay. This is the first one. This is Hofmann ammonolysis method. The next one is another suppose I have the RCl and I do not okay, the second one is from cyanides. Okay, so we can prepare it from cyanides, but the main application for this preparation is that suppose I have CH3Cl, okay, and I have to prepare. Let us take an example question. CH3Cl, and from here I have to prepare CH3CH2 NH2. Okay, so here is one carbon, and in this case you have two carbons. So you are increasing the number of carbons. So this type of reaction is known as ascent of series. You're increasing a carbon number 1 or 2. So you're doing an ascent of series. For this type of reactions, we will prefer the preparation of amines from cyanide. So what we will do? We will first react this RCl with KCN, alcoholic KCN. Okay. We will get this CN. Okay, alcoholic KCN, we will get this CN. Okay. Understood?
Yes.
Okay. This is a substitution reaction and this is an SN2 reaction because 1 degree alkyl halide and it will undergo SN2 reaction. Now, we have to add here any reducing agent like LiAlH4 or H2Ni. Okay, we can use LiAlH4, H2Ni, or even we can use sodium over ethanol. Okay, not sodium, sodium amalgam over ethanol. Okay, and we will get CH3, CH2, and H2. Okay, so this is alkyl chloride to this is alkyl cyanide. And from here you are getting this amine. Okay, so reduction of cyanide, you will get an amine with increase in carbon number. Okay, so to increase the number of carbon, this type of reactions are performed. Okay. And when we are talking about increasing the carbon number, so if I have another form of reaction can also be done for having these things. Like if I have like if I have an carboxylic acid, okay, CH3. So next is from amines, In the chapter of carboxylic acid derivatives, we have already understood that carboxylic acid. So we will also take an example from here, question example, that from carboxylic acid, you have to prepare CH3, CH2, NH2. Okay, ethylamine. From ethanoic acid, you have to prepare ethylamine. So what you will do? First, you will do this NH3 and heat, and you will get CH3, C double bond O, NH2. Okay, and over this, you will just have to apply a LiAlH4 or sodium over ethanol, not sodium amalgam. Okay, it is only sodium over ethanol, and you will get CH3, CH2, NH2. So when we are doing some preparation of one chapter, we should always be, we will always have to take something in our mind that this preparation is a reaction of some other and some other functional groups. Okay, so we have to be cautious about what we are doing. So this is the basic requirement to understand about to learn about the preparation of any amines or any reagents or any type of functional groups. Here NH2 is a functional group. Suppose you have to prepare OH from here, means alcohol from here. So you need to also know that this amines, we have already learned in the chapter of alcohols, that if I give here NaNO2 and HCl, I will get CH3, CH2, OH. Okay, if I give NaNO2 over HCl, I will get CH3, CH2, OH, which is ethanol. Okay, so this is the thing that we need to understand, that from one place we can go, but we cannot directly prepare. We can also directly prepare ethanol from this carboxylic acid as well. We have to reuse it with LiAlH4, then we can get this ethanol, or we can reduce it with BH3 over THF and we can get this ethanol. So these are the things that we need to know. Understood? Next, what we can do, and this reduction of amines, alkyl cyanide to amines, is known as Mendius reaction. Okay, this is known as Mendius reaction. The fourth form of preparation is preparation from nitro compounds. Okay, preparation from nitro compounds. So how to prepare from nitro compounds? This is also another method where I have RNO2 and I can use either SnHCl or FeHCl or even H2PD. Okay, and sometimes FeNH4Cl or even LiLH4 will also reduce this nitro to amine. Okay, so actually the most important reagents are either SnHCl or FeNH4Cl. The others we may or we may not use. Okay, because SnHCl and FeNH4Cl are, and Fe sometimes you can use this as well. But these two, if SnHCl and FeNH4Cl, are used specifically to reduce this NO2 to NH2. Okay, this is a specific reaction. Reduce NO2 to NH2. The next one is Hofmann bromamide degradation. Sorry. Hofmann bromamide degradation. So we have just learned about the preparation of amines from an amide. But in that case, the CO was reduced to CH2. Now, if you have this question, example question, that you have this CH3COOH, but you have to prepare methylamine from here. That is, you have to remove a carbon atom. This is known as descent of series. That was ascent of series when we are going from CH3Cl to CH3CH2NH2. Now we have to go down the series. That is, we have to perform a descent of series reaction. So here CH3COH to CH3NH2. This is the main concern. This is the main conversion of concern which will be given to us. So here what we will do, we will first convert this to our amide. Okay, NH3 and heat. And then we will get CH3 C double bond O NH2. Okay, with water as a side product. So this is our amide. Okay, now we will give here Br2 over KOH and we will heat it. And what will happen from here is that we will get CH3 NH2. Okay, you will get CH3 NH2. The CO will move out from the system. Okay, it will form carbon dioxide, obviously. So this is descent of series. Okay, this is descent of series. We are going one carbon. Yes. Last one is Gabriel Phthalimide synthesis. Okay, so Gabriel Phthalimide synthesis. So what is a phthalimide? A phthalimide is something which can be prepared from phthalic acid. Phthalic acid is 1,2-dibenzoic acid. If you heat it with Al2O3 at a very high temperature, then you will get this phthalic anhydride. Then you have to use ammonia. Then you will get this phthalimide. Okay, this is phthalimide. Okay, this is phthalic anhydride, this is phthalic acid, and this is phthalimide. Now what we will do, we will at first remove this hydrogen from this nitrogen. So we will use a base, KOH. We know I have already stated that nitrogen has a lone pair, but this lone pair is involved in resonance here. So this hydrogen is free for abstraction. Okay, this hydrogen is free for abstraction, and with a little amount of KOH in alcoholic medium, you can get this negatively charged nitrogen atom. Okay, and to here you have to give an alkyl halide. This is also a very good method to prepare 1 degree amine from an alkyl halide without going for that Hofmann ammonolysis method. Okay, so we will get this. Okay, this is the thing, that is the alkyl phthalimide will get. And if you give here H plus or OH minus, okay, anything, so it will break from here and you will get only 1 degree amine. Okay, you will only get 1 degree amine and nothing else. So this is the main thing that you can get. Understood? Now, there is a little bit of drawbacks of this reaction. So what are the drawbacks? See, in this method, we are using an alkyl halide. So the main drawback is we can use only alkyl halide. We can use only alkyl halides and not aryl halides. Okay, that means what? Aromatic amines cannot be prepared by this method because aryl halides are not susceptible to any SN2 reaction or SN1 reaction. It will not undergo any substitution reaction. What is this? This is SN2 or SN1 type reaction. Okay, mainly SN2 reaction. So aryl halides does not undergo SN2 reaction. So we can use only alkyl halides. Okay, we can use only alkyl halides. The next thing is that it can be used for the preparation of 1-degree amines, but when like tertiary butyl means like if I want to prepare, if we want to prepare 3-degree amine, if we want to prepare a 3-degree amine or want to prepare 1-degree amine with a 3-degree carbon, then elimination reaction will take place. Okay, that means this SN1 type is very rare, and the most form is that without going to SN1 pathway, it will go to the E1 pathway. Okay, that means elimination pathway will be favored if I use R as C, CH3, CH3, CH3. Okay, this will give rise to E1 reaction, not SN1 reaction. Okay, understood? So these are the main things you have run. So till here, I think there is no confusion. So we have completed up to the preparation of amines. Okay, aliphatic amines, 1-degree aliphatic amines. And in our next classes, we will go for the next part of the chapter. Okay, that is aromatic amines and the main reaction. Good. So let us just a minute. Yeah, let us stop here.